Hello, welcome to class today. In today's class, we're going to be talking about algebra. Algebra begins with your open sentences. Okay, so that's the simplest point you can start. You remember open sentences where you have a box and it said plus 5 is equal to 11. So they want you to write what is going to be in the box to make this true. And we know that if we add 6 here, then 6 plus 5 will become 11. Okay, so an open sentence is a mathematical statement that involves equality signs. This is an equality sign and a missing quantity, which is usually represented by a box. Okay, so in open sentence, there is a missing quantity that will be represented by a box, okay, which you're going to find. All right, now as we'll advance and we later know that this open sentence transforms into algebraic equations. And when we talk about algebra, we mean a kind of mathematics that deals with letters and numbers, that treats letters and numbers. So the idea behind algebra from open sentence is that instead of writing this box, we now use letters to represent the box. So instead of saying box plus 5 is equal to 11, we can write y plus 5 is equal to 11. So this is the same thing as box plus 5 is equal to 11. So the only difference is that instead of the box, we write y. Okay, we're not using y to represent the box. So that box there is like a container and is empty, and we need to fill it with a number that will make the equation to be true. So that box that is now represented by the y, letter y, is what we call a variable. Okay, so in algebra, a variable is like a container. A variable is like a container. In fact, that's the reason why it was a box. So anytime you see a letter, that letter, you should visualize it like a container that needs a value that will make the equation to be true. So a variable is a container that can accept any number. Now you can see that an open sentence is an equation. Okay, an equation is a mathematical statement where you have an equal to in this at the middle. You have some things at the right hand side. RHS stands for right hand side, and you have some other things at the left hand side. So if you have this kind of mathematical statement where you have some things written on the left hand side with an equal to in the middle and some things written at the right hand side, then what we have is called an equation. So if you look at this, you see that this is an equation because we have a box plus 5 on the left hand side and we have 11 on the right hand side. Okay, so let's go back to our initial example where we had a box plus 5, okay, is equal to 11. Okay, this is very simple to solve. You can just reason and say, yes, what will I add to 5 to give me 11? However, when we begin to solve more complicated example, more difficult example, we need to develop a method for finding whatever is supposed to be in the box. Okay, so for us to solve equations, there are a few rules we have to follow to make finding this number very simple. Okay, and one of the very easy way to do that is what we call the balance method. So balance method, when we talk about balance method, it is simply whatever you do to the left hand side, do the same thing to the right hand side. That's the simplest way to explain balance method. When we talk about balance method, we can add the same thing to the left hand side and the right hand side. We can subtract the same thing from the left hand side and the right hand side. Okay, we can multiply left hand side and right hand side by the same thing, when I mean the same thing here, I'm talking about the same number, or it could be an alphabet. We can also divide. Okay, we can also divide left hand side and right hand side by the same number. And I need you to understand this. Anytime we use balance method, the value of the equation, the sense of the equation does not change. Okay, so let me show you what that means. If we have 2x is equal to let's say 6, if we multiply this equation by 2, multiply left hand side and right hand side by 2, I did the same thing. I'm going to have 4x is equal to 12. So these two equations, they have the same value, and the reason is because I did the same thing to the left hand side and right hand side. You take your mind back to fraction. If we have a fraction just like 6 over 12, remember that this fraction is the same thing. If we divide both numerator and denominator by 3, this will give us 2. If we divide this by 3, we get 4. So 6 over 12 translates to 2 over 4. Because we use the same number to divide 6 and 12, these 2 over 4 and 6 over 12, they are equivalent fractions. They are equal fractions. We can still divide this 2 by 2, and we can still divide this 4 by 2 to give us 1 all over 2. So 1 over 2 is the same thing as 2 over 4, and it's also the same thing as 6 over 12. So this is a similar thing that is happening to equations. Anytime we do the same thing to left hand side and right hand side, the equations do not change. Their value do not change. Okay, they are still the same thing. Okay, so what we're trying to say is the reason we're doing the same thing to the left hand side and right hand side is so we do not affect the value of the equation. So just like when we divide numerator and denominator of a fraction, the resulting fraction we get is equivalence, is the same thing. Even if we multiply, let's say we have 3 over 5. Remember, if we multiply numerator and denominator by the same number, let's say 10, this will give us 30 over 50. 30 over 50 is still the same as 3 over 5 because we did the same thing to the numerator and denominator. So I'm emphasizing this so you understand. The only time this equation is going to change is if we do this something to just one side of the equation, then the equation is going to change. But if we do the same thing to the left hand side and the right hand side, the equation does not change. Okay, so let's take some examples. So in the first example, we have find the value of x in x plus 9 is equal to 34. X plus 9 is equal to 34. Now, anytime you see an equation, remember that later you're looking at is like a box. So we're having like a box plus 9 is 34. So what the question requires us, if it is an open sentence like this, it requires us to put something inside the box. So anytime you're asked to solve an equation, your eye should first of all go to the variable. It means that we want to put a number in that variable that will make the equation to be true. Okay, so like we mentioned, we can add the same number to both sides, we can subtract, we can add, we can multiply, and we can divide. But how do we know which of them to do? So the aim of solving an equation, take note of this, is to put only the letter on one side of the equation and every other thing on the other side of the equation. Okay, this is what we mean by solving an equation. We want to isolate everything and then put just the letter on one side. So the letter can be probably on the other side and everything on the left side, or the letter can be on just the left side and everything on the other side of the equation. When we have done something like this, we said we have solved the equation. So for this equation, how do we remove 9? Okay, so that is the only thing with x on the left hand side, which means we need to remove plus 9. We need to remove plus 9. How do we remove plus 9? We know that 9 minus 9 will give us 0, and once we subtract 9 from this 9, we get a 0, and what is left on the left hand side is going to be x. So since we're going to subtract, this is what's on the left hand side, we subtract 9. Okay, we subtract 9. Because we subtracted 9 from the left hand side, we are going to do the same thing to the right hand side. Remember, it's called balance method. Anything you do to the left hand side, do the same thing to the right hand side. So here we are going to have 9 minus 9 will give us 0, and we're only having x. So this is the actual reason why we did 9 minus 9. So we leave only x on the left hand side. Okay, so is equal to 34 minus 9 will give us 25. So the value of x is equal to 25. Okay, and you can see if we have a box plus 9 is equal to 34, what is going to go into this box is 25, and 25 plus 9 will give us 34. Okay, so we just subtracted the same number from both sides. Let's take the next example. In the next example, we have 3 plus y is equal to 15. 3 plus y is equal to 15. So what do we do? The only thing that is with y here is 3. So we are going to subtract 3 from both sides. So what's on the left hand side is 3 plus y. We say minus 3. Why are we doing minus 3? Because we want to subtract 3. So because we subtracted 3 from left hand side, we're also going to do that to the right hand side. So 3 minus 3 is 0. We have y is equal to 15 minus 3. That gives us 12. Let's try the next example. In the next example, we have p plus 6 is equal to 8. P plus 6 is equal to 8. So by now we should know what we're supposed to do. We have a plus 6. So if we remove this plus 6, P will be left alone. Okay, so to remove plus 6, we subtract 6 from both sides. So we have P plus 6, we subtract 6, and then 8, we subtract 6. What we do to the left hand side, we do to the right hand side. So 6 minus 6 is 0. We're just left with only P, which is what we want. 8 minus 6 is 2. Okay, so let's take one final example. Final example, we have x plus 3 is equal to 8. Okay, so what do we do here? I'll just wait a little bit. Can you solve this before I solve it? Okay, so because we have a plus 3 here, we're going to subtract it from both sides. So on the left hand side, we have x plus 3. We subtract 3, and then 8 will also subtract 3. 3 minus 3 is 0. We have x alone. 8 minus 3, we have 5. Okay, all right. So before we go ahead, we need to understand a few things. Okay, so this is what we call inverses. We have multiplicative inverse, we have additive inverse, and I'll show you what that means. Okay, so when we talk about additive inverse, is a number you add to another number to get a 0. So the additive inverse of 3 is minus 3, and the additive inverse of minus 3 is 3. Now, by the way, every number is either positive or negative. So if you see any number with a minus sign, it means that number is negative. If you see any number without a sign, it means that number is positive. And the sign of a number is actually the sign behind here. If I have something like 3 minus 3, it is this 3 that has the negative sign. This other 3 has a positive sign which is not written here. Like I said, if a sign is not written together with a number, then that number is positive, and the sign of a number is the sign at the back of the number. Okay, so if we have 3 plus 4 minus 2 plus 8, then what that means is that this is a plus 8, this is a minus 2, and this is a plus 4. And 3 is now going to be a positive 3, even if the positive is not written. Okay, so the sign of a number is the sign at the back of the number. Okay, you understand that now? Yes, because this is going to we're going to use this in the next series of examples. Okay, so now back to additive inverse. Okay, so if we have 3, the additive inverse of 3 is minus 3. Okay, if we have minus 2, the additive inverse of 2 is 2. So the additive inverse of a number is that number with an opposite sign. If it's a positive of that number, the additive inverse is going to be the negative of that number. So additive inverse of minus 1 is 1. Okay, always remember that this is plus 1. Okay, so what will be the additive inverse of plus 9? That will be negative 9. Additive inverse of minus 11 will be plus 11. Additive inverse of minus 20 is going to be plus 20. So what is it with additive inverses? Additive inverse, when we combine them, we get a 0. So minus 11 plus 11 is 0. Minus 20 plus 20 is 0. Plus 9 minus 9 is 0. Okay? Minus 1 plus 1 is 0. So this is what makes them additive inverse. Their result is 0. Their result is 0. Their result is 0. Take note of this. It's very, very important. The result of additive inverses will give you 0. The sum is 0. So minus 11 plus 11 is 0. Plus 11 minus 11 is 0. Whichever way they come, whether the minus comes first or the plus comes first. So far the numbers are additive inverse of each other, then their result is going to be 0. Okay, so what that means is minus 2 plus 2 is 0. Anytime you come across it is 0. Okay, minus 10 plus 10 is 0. Plus 10 minus 10 is also 0. Additive inverses. Okay, now that we're familiar with additive inverses, let's proceed to solve more examples. So in this example, let's have 3 plus p is equal to 11. Okay, remember that this is a positive 3. That's a positive 3. So if we have a positive 3, what are we going to do? We subtract 3 from both sides. Subtract 3 from both sides. Subtract. So we have 3 plus p, we subtract 3, is equal to 11. We subtract 3. So 3 minus 3, additive inverse. Okay, that will be 0. P is equal to 11 minus 4 is equal to 8. Okay, so now let's have x. So x minus 2 is equal to 6. X minus 2 is equal to 6. You can notice that in all the examples we're solving, we have been having positive numbers. In this case, we have a negative number. So how do we remove a negative number from the left hand side to leave the x alone? That's where the idea of additive inverse comes into play. Since we have a negative 2, we're going to add 2 because plus 2 is the additive inverse of minus 2. Okay, so we have x minus 2, we add a plus 2, and then we have 6, we also add a plus 2, because anything we do to the left hand side, we do it to the right hand side. Minus 2 plus 2, they are additive inverse, that's 0, so we have x is equal to 6 plus 2 will give us 8. Okay, are you following? I hope you're following. Okay, so let's have y minus 13 is equal to 6. Y minus 13 is equal to 6. We need a number that will make 13 0, and exactly that is the additive inverse of 13. So if we have minus 13, additive inverse of minus 13 is going to be plus 13. So y minus 13 plus 13, y minus 13 plus 13, that will give you 6 plus 13. We added 13 to the left hand side, we'll also add 13 to the right hand side. Why did we choose 13? Because here is minus 13, and 13 is the additive inverse of minus 13. So minus 13 plus 13, additive inverse, it will give us 0. So y will be equal to 6 plus 13 is 19.